J. Explain the purpose of Structured Query Language, SQL. Structured Query Language, SQL, is a standardized language used to manage and retrieve data from relational databases. It allows users to query, update, insert, and delete records efficiently. SQL supports data extraction for analysis. Analysts use SQL to filter datasets, aggregate results, join tables, and prepare data for reporting or advanced modeling. T enhances data accuracy and control. SQL enforces data validation rules and supports access permissions within database management systems, ensuring that data retrieval and modification occur securely and consistently. K. Describe how an analyst would mine large datasets to reveal patterns and insights. The process begins with defining objectives and preparing data. Analysts clarify business questions, consolidate relevant datasets, and perform cleaning and transformation to ensure quality and consistency. Next, analytical models are applied. Techniques such as clustering, classification, regression, or association analysis are used to identify trends, correlations, and anomalies within the data. Finally, results are interpreted and validated. Analysts evaluate model accuracy, test assumptions, and translate findings into actionable insights. Continuous feedback and refinement ensure the analysis remains aligned with business goals and decision-making needs. L. Explain the challenge of fitting an analytics model to the data. Model fitting requires balancing accuracy and generalizability. An analytics model must capture meaningful relationships within the dataset without overfitting noise. Overfitting occurs when a model performs well on historical data but poorly on new data because it is too complex. Data quality and variable selection complicate model design. Missing values, outliers, multicollinearity, and irrelevant variables can distort results. Analysts must carefully pre-process data and select predictors that align with business objectives. Validation and testing are essential. Techniques such as cross-validation and out-of-sample testing help ensure that the model performs reliably and provides actionable insights rather than misleading conclusions. M. Define descriptive, diagnostic, predictive, and prescriptive analytics. Descriptive analytics summarizes historical data. It answers what happened through reports, dashboards, and key performance indicators, supporting performance monitoring and benchmarking. Diagnostic analytics explains causes of outcomes. It addresses why did it happen, using drill-down analysis, correlations, and variance analysis to identify drivers of performance. Predictive analytics forecasts future events. Using statistical models and machine learning, it estimates probabilities and trends. Prescriptive analytics goes further by recommending optimal actions based on predicted outcomes and decision models. N. Define clustering and classification and determine appropriate usage. Clustering is an unsupervised learning technique that groups similar data points. It identifies natural patterns without predefined labels, making it useful for customer segmentation, market analysis, and anomaly detection. Classification is a supervised learning technique that assigns data to predefined categories. It relies on labeled training data to predict class membership, such as credit approval decisions or fraud detection. Appropriate usage depends on the objective and data availability. When categories are unknown, clustering is appropriate. When historical labeled outcomes exist and prediction is required, classification techniques are preferred. O. Demonstrate understanding of multiple regression and logistic regression. Multiple regression analyzes relationships between one continuous dependent variable and multiple independent variables. It estimates how changes in predictors affect outcomes, making it useful for forecasting sales, costs, or financial performance. Logistic regression is used when the dependent variable is categorical. It estimates the probability of binary outcomes, such as default versus non-default or success versus failure. Technique selection depends on outcome type and assumptions. Multiple regression is appropriate for continuous metrics with linear relationships, while logistic regression is suitable for probability estimation of categorical events. P. Calculate the result of multiple regression equations in a specific situation. Multiple regression estimates a dependent variable using several independent variables. The equation typically takes the form y equals a plus bx plus b2x2 plus bx, where coefficients represent the expected change in y for a one-unit change in each predictor, holding others constant. Application requires accurate substitution and interpretation. Analysts input known values for independent variables into the equation to calculate predicted outcomes such as sales, costs, or demand. Managerial insight depends on interpretation. Beyond calculation, managers must evaluate the economic meaning of coefficients, ensuring results align with operational realities and decision-making needs. Q. Demonstrate understanding of coefficient of determination, R superscript 2, and correlation coefficient, R. The correlation coefficient, R, measures the strength and direction of a linear relationship between two variables. Values range from -1 to +1, indicating negative, positive, or no linear association. The coefficient of determination, R superscript 2, measures explanatory power. It represents the proportion of variation in the dependent variable explained by the independent variables in the regression model. Interpretation requires caution. A high R superscript 2 does not guarantee causation or predictive accuracy. Analysts must consider model assumptions, omitted variables, and potential multicollinearity when evaluating model strength.